Hey everyone, welcome back to my weekly GameDevElement stream. Today we're going to talk about a topic. Actually, it was a question asked by someone who watches the stream, and basically the question was whether a computer science study program is better or worse than a programming uh, line of study. Obviously, it was a bit more nuanced than that, but that's the essential core of it. Now, to give some context, this is in terms of a university level course of study, so at a degree level, but it applies to practically anything. I see Brandon's here. Hi, Brandon. So, first off, we'll define what one understands by computer science and what one understands by a programming degree or a programming course. But before that, my short answer is computer science is theoretically more practical than a programming centric degree. And I'll explain why. So that's the short answer. The actual answer is a bit more nuanced than that. And it's actually very similar to a broader question. All of this is in terms of general programming and even applies specifically to game development, whether computer science is better than programming. So it applies in either way. Oh, hi, Dearest Cake, thanks for the follow. It is a similar answer to the question of whether to study something formally at university degree, at whatever level of study you are, whether to approach that formally or whether to learn that by yourself through experience, through working for a company, through doing stuff on your own. So whether it's formal study versus personal experience, right? It's the same concept, and I'll explain why. So first of all, what I'm not saying is that if you do not study something formally or if you do not have a university degree, it doesn't mean that you're not good. And the opposite applies as well. If you do have a university degree, if you have studied something formally, it does not mean that you are good. So I'm not correlating studying versus being good at what you do, or not studying versus not being good at what you do. So that's not the issue here. You still need to learn, whether it's formally or on your own. So that's immediately, I want to make that clear. So you need to study somehow, whether it's through a formal course, whether it's through a school, a university, private tuition, whatever, or if it's on your own, or if it's through experience. Experience is learning at the end of the day, and it involves some studying, whether you're reading books, whether you're watching online tutorials or stuff. To some degree, that is studying. And you have to do that. What university is, or what formal learning is just an accelerated version of lessons you can learn the long way doing them on your own. So for example, if you're at some kind of lesson and the lesson tells you, look, this is normally the best way to do this kind of thing because of A, B, and C. You have other options, but they might not be that good in these kind of situations. And that's done in, say, a 1-hour lesson. Learning that on your own might take longer, it might take more mistakes. So university structured learning might be a bit more guided in that sense. It doesn't mean that it's a replacement for experience. It means that it saves you just a small part by pushing you in the right direction. Again, whether it's university or whether it's some other form of... So it's not about university, it's about structured learning. Secondly, it is just a... Sorry, not secondly, this is a separate note. University provides you a stamp of approval from a recognized body, and there are different levels of recognition, that employers can look at and have a somewhat Not guarantee, because you could go through university and end up not learning anything, and you could be the whatever. So university on its own does not mean anything, but employers do look at that generally favorably, and that gives you more opportunities to start working and gain that all important experience. So looking at myself as an example, I do have a university degree. It was a 4-year degree or 4-year degree. But in the first 4 or 5 months of full-time employment at a software house, my background is coincidentally computer science and artificial intelligence. I learned much more than I learned in those 5 months. I learned much more than I did during the previous 4 years of university. However, I would not have learned so much in those 6 months, initial 6 months of work, had I not gone through the formal learning offered by my course of studies. So they're complementary. That same logic, I'll apply that to one more concept, and I'll bring it back to how this relates to computer science versus programming. That same logic of university or whatever course giving you a bit of a guided, path to your learning, is because university or a certain level of education teaches you how to learn, does not teach you specific answers, right? So it gives you the tools you need to learn whatever you need to be learning, and that is very important, especially considering the specific industry we're in. So computers, IT, it's a very new industry, it's constantly changing. What I learned 8 years ago now, I finished my degree, most of it is obsolete. Most of the specific knowledge, the concepts, most of them are still there. Which brings me now down to computer science versus programming. Computer science is a more of an overarching topic, as the realist cake just said. So it's learning about what IT is. It's learning about programming concepts. It's learning about certain IT concepts which might relate to hardware, which might relate to project management, which might relate to systems design, which might relate to a wide variety of things and how they're interlinked together. It does not necessarily go into as much depth as a programming-centric course does. So I'm considering computer science versus programming at the same level of studies here, right? Because in the context of this question, we were talking about the University of Malta, specifically the courses they offer, and they have a computer science course and a programming-centric course. Although the terms are wide in their definition, they generally fall under this description. So programming would be learning certain coding principles, certain programming patterns, certain way of programming certain stuff properly. I might assume that it would have a greater focus on different language types. So things like object-oriented languages, things like declarative languages and how they differ, things like component-based languages, like the way Unity is designed, this and that kind of thing. So it's more focused on the actual software creation and the techniques which you use. Computer science is a bit more high level, and it relates to how I'm linking university learning versus learning a specific task, because if you know computer science, part of understanding computer science involves programming. So you will be exposed to programming automatically, but with the added knowledge that you know how to apply that programming within the grander scheme of things. So programming is more of a skill which you can learn on your own as you do other stuff. A programming degree might go into a lot of detail, but at the same time, I think it might go into a bit too much detail if you're looking at something like a quote-unquote software engineer role, which is a bit more overarching. I think programming degree is a bit narrower and deeper, it's a bit more focused. I think having a computer science degree, which is a bit more overarching, it's still focused, So it's computer science and including artificial intelligence in there, hopefully. That is not too narrow and sufficiently deep for a person who is into software development. That is what I think about this subject. So programming you can get on your own. You will get into that with computer science. Small anecdote, we were learning, what was the topic? I think it was systems programming. The course was called, the specific lessons were called. It was related to, very low level programming. So basically it was in C. It was related to, if I'm not mistaken, developing operating systems and that kind of technology. So very, very, very low level stuff. And none of us, or very few of us, knew C. C is a hard language, it's a very powerful language, but it's very difficult to grasp at first. We were given 2 weeks to be comfortable with C, learn C, and start using it. And the project or assignment was going to be in C. Now, why am I saying this? It is because at a computer science level, you are expected to get familiar with these kind of things because they are bread and butter, they are part and parcel of everything. Now, you will not be an expert or a top-notch C programmer just by that, but you will have a good grasp of that kind of language. And you get to apply that in different concepts and socket programming and all this and all that, and it gives you a good grasp of what's going on. If that makes sense. Let me give you another example. I have coincidentally this week I grabbed my database book again. I had this at university, the El Masri and Navate book, if you've seen this. And I brought it out today because this might also give an idea of the distinction between learning a tool, a skill like programming or a specific programming language versus the higher overarching concepts of computer science. In this case, databases. So this book is about if it's not apparent, it's 1,000 pages long, and it has about 30 chapters. The first 2 chapters, or the second and third chapter, deal with SQL, so the scripting language for databases. That is 2 chapters, which in total, they start from page, where is it? Come on. Page 15, and keep on going until about page 70. So that's 55 pages out of 1,000 dedicated to SQL. The rest is all database related concepts. So learning how to manage a database is way beyond learning how to query a database and get the information you need from a database or save to a database. It involves database design, it involves server management, the hardware server, it involves the database server, so the software, whether it's MySQL or Oracle or whatnot. It involves principles of security, it involves principles of optimization, it involves principles of this and that. So one might think, databases, SQL. Let's learn SQL and we know databases. No, of course you don't. Same thing with programming and computer science. So if you want to be a software engineer kind of person, computer science is the way to go. If you just want to code, you just want to ignore some aspects of software design and just want to have a designer be part of a whole team and be the programming part, and you want to specialize in that, then you might want to go for a programming degree. I still think that might be a bit limiting in terms of scope, so I would still suggest computer science. But that is my opinion. That is the realist cake's opinion. That might not be what other people think, but I've tried to explain why I'm saying that's the logic behind it. If that makes sense to you, I hope that that is something which you can take away and apply to your own specific situation, because obviously you're the only one. When I say you in this case, I'm referring to the person who asked the question. You're the one who knows your own situation. You need to take away the lessons from that explanation. At the same time, if you do have any specific question or you would like me to elaborate on something more specific, I know you're watching right now, just fire off a question in chat and I'll address that specific thing. Now I want to touch back on the university studies. So I'm using university as a replacement for, you know, post obligatory school, so tertiary level education, right? Whether it's university, whether it's a trade school, whether it's what have you. I am also an avid believer that university studies, tertiary education basically, should happen from people. It doesn't mean that that university is for everyone. It doesn't mean that university is a guarantee of anything. But I think if it's not in your area of studies, going through the process of a tertiary education, going through a university degree, an undergraduate degree, is a rite of passage which in and of itself gives you a certain outlook on how to approach things. It's tough, it's hard, it's a challenge, it's sometimes unfair. The grading system, the way we assess people is grossly wrong. It's unfair, it's hard. I think it does not give an accurate assessment of a student's abilities, whether in the positive or the negative. I think it's a way of mass assessing students, so it doesn't necessarily work, but the process is very important. After those 4 years, whether you get a first-class degree or your regional equivalent or not, doesn't make a difference. You've gone through the process and you've survived it, which will prepare you for the real world, for the world of working in a team, of working with others. So there's teamwork concepts, there's the idea of being immersed in a project which you might not be totally familiar with, and you need to get up to snuff in a matter of weeks. You'll do that time and time again at university, so you'll be accustomed to doing that. There's the concept of assessment not being fair, and how will you deal with that? So it's even a rite of passage as a person for character building, but you know, in your professional line of work. So you get to your job, you get thrust in a team which you might not know. New project, new situation, new deadlines, new people you need to work with, new boss, new everything. It might be a new language, a new programming language. It might be a new concept, a new methodology. You have done that dozens, if not hundreds of times throughout your 4 years at university. And when you get to that point, at least that very hard aspect of employment is not something new for you. So the shock of employment, which is completely different from university, but it builds on, is somewhat cushioned, right? So it's already a good thing in that way. Even if you start working on your own, if you branch out as a freelancer, same thing. You're your own boss, so it's even more important to be accustomed to certain practices. Yes, I agree, Brandon. That's exactly it. Computer science encompasses programming. It might not be a module of computer science. It's more of an ever-present aspect of it, or an ever-present aspect of some of it. Some modules might focus on certain programming concepts, yes, but there will not be a specific module, this is programming. Not really. Not really. There might be some modules which would say programming in declarative languages, for example, and you'll be exposed to something like Lisp, for example, or Haskell, if I'm not confusing the names there. But that's because those are more esoteric kind of language paradigms, and the point of the module would not really be to learn Lisp or Haskell or what have you, but to get the larger idea behind the concept. So programming would be inbuilt to computer science. Computer science goes way beyond that, but it has to use programming in most of its modules as a tool. One example of a more programming-centric module would be, I don't know, principles of object-oriented programming. So you'd go into stuff like inheritance and stuff like abstraction, which would teach you the object-oriented way, but at the same time you'll be getting out certain data structures out of those, certain algorithmics which you'll be using. That's a very important aspect of computer science, algorithms. So the way to approach algorithms, what makes an algorithm strong, what doesn't, how detailed should you need to go in your abstraction and this kind and this and that. So that teach you good principles, which you then on your own apply to programming. Programming might go into those specifically and at a very deep level, but computer science still covers those because they apply across the board. I think that the value which computer science, the appreciation of IT, which computer science gives you, a programming-centric course does not. Computer science, at least back when I was studying it, even went into some engineering aspects, some hardware stuff, down to the CPU, how that works, and that makes sense because if you are programming, you could be programming concurrent systems, you could be programming at an operating system level, you could be programming kernels and whatnot. So how can you do that if you do not understand how a microchip works, what a full adder is, what goes on at hardware level? If you are programming in that low level type of code, you're interfacing directly with the hardware. So you might know the programming aspect, but if you don't know the hardware, then how well could you be knowing the programming aspect of that? So I think programming might be a bit more limiting. One more important aspect, but this is not really specific to just programming versus computer science, it's specific to the concept of focusing in depth too early in your career. So that applies to any subject, whether you're in legal or accounting or architecture and all that. If you focus too much too early, your options are very limited in life. You can't pivot very easily. So for example, I know engineers who came into IT. The engineering course had some aspect of IT and it enabled them to pivot. They pivoted into bioinformatics or bioengineering because their course touched very briefly on those and they applied their knowledge to a completely different field as opposed to your traditional mechanical and electrical engineering. I know many IT people who pivoted into dozens, not millions, but dozens of other industries because IT can be applied anywhere. Whereas if you went down the programming route, you might be locked into a certain type of programming system applications or programming business applications, and you can't apply your knowledge to different areas. Few years down the line in your career, you might get bored with your career choice and you might want to pivot. If you focus too much too early, your options might be limited. Take me, for example. I studied computer science and artificial intelligence. I pivoted very early after about 4 years of working into working at a traditional software development house into game development. Now game development is much more than games programming. It involves managerial aspects, it involves business aspects, it involves marketing, it involves game design, it involves a lot of things. a large component of that is naturally programming the game itself. So I used my computer science knowledge to leverage that into programming games, and then through programming games pushed outwards into the whole spectrum of game development and producing games and creating games. So I hope that these small anecdotes are giving you a better idea of why I think computer science is better than programming within the context of the question that you had asked me. Now, if I remember correctly, you said that you've been building games for a while, for about 5 years, and you wanted to get into programming or modeling for movies. That's exactly the same concept that I'm saying about pivoting into something. So I can guarantee that learning programming is not going to prepare you specifically for whatever application of programming you want to do, in this case movies or media or whatever. Computer science will give you those skills. You'll even get used to using, I don't know, 3D modeling software, even if it's nothing to do with 3D modeling, but part of your assignments and part of your work, you'll touch somewhere with graphics and game engines and this and that. So you get some experience in different fields, and you can get a better idea of what you want to get into later on in life or in the immediate future, in 1-2 years time. I myself, I went into IT and I knew I wanted to do something with IT, programming or design or something like that, but I had not much of a clear idea in which direction I wanted to take that. I knew some things I did not want to do, and I thought I knew exactly what computer science and AI was all about. I did not. I had a good grasp of a very small portion of what CS was. So over the period of 4 years of study, it let me understand better what computer science involved, which parts of that I liked, which parts of that I didn't. It helped me get the tools to be familiar with stuff which we did not learn and I knew was out there. So for example, I was mentioning databases. Our databases lectures were horrible. They were terrible. The lecturer we had simply regurgitated stuff out of the book. Sorry to say that I didn't feel that person was a good lecturer. In fact, my database skills were not that good. But after those 4 years or throughout those 4 years, my IT skills were refined, they were sharpened, and I was able to get databases and be very proficient with database concepts on my own because I had the supporting knowledge to do that. I just lost my train of thought. I wanted to mention something else and I forgot what that was. Let me see if I can remember that because I think it was somewhat important. I was talking about not knowing fully, appreciating fully what I was going to get. Yes. We had a course which was related to game engines. Sorry, was related to graphics. And it was low-level graphics. Back then, XNA was all the rage. It was the next best thing, the new thing. So it was a Microsoft's framework over pure DirectX. So it was DirectX and OpenGL. And we were learning those, and we were learning XNA, and we had our assignment. And I decided to take, I realized that I enjoyed graphics programming. So I decided to take my assignment to a slightly higher level, and I created a miniature graphics engine. So think Unity, but at a much smaller scale. But just for graphics, to create graphical stuff and animating them. So I applied the knowledge we learned at that course, extended that to a generic engine, and then I asked with an interface and a graphical interface, and I asked that engine, I could tell that engine to do what I wanted it to do. And that made me realize that I enjoyed that part of things, and it's partly the reason why I am in games development right now. I realized that scientific stuff, really technical stuff, mathematics at the end of the day, IT, right, programming, very rigid, could be leveraged very artistically and that way. So it allowed me to be very rigid and yet at the same time very rigid, very organized, very structured, and at the same time express myself artistically. And you realize that. That was in our third year of studies, I believe. And it kind of gave me a push in that direction, although I ended up starting with a more traditional development job, which, surprise, surprise, did not fulfill me creatively as an IT guy, as a programmer, as a designer. But it was a means to an end. But business software was a bit blah for me. But for some people, that's challenging. That's enjoyable. The challenges offered by business applications are for some people. They're not for others. During my course, I realized that I did not enjoy web development. Absolutely hate it. But I realized that it is a very powerful tool for business, or for a software house, or for a program creator, because it takes away the problem of well, fragmentation of devices is still there, but somewhat lessened. It removes the problem of installing stuff. It removes the problem of supporting different hardware. If the browser supports it, you're done. It has its challenges, which I absolutely hate, but it has its advantages. And my computer science degree let me appreciate that, versus programming, which might have taught me how to create websites, how to create web pages, how to create backends for web pages, but I might not have realized the different benefits or downsides to web development, and I might have chosen a career in web development which would have been a disaster for me, because I hate web development. Many people love it. I see how it is very interesting. I myself, it's not for me. So to each his own, and that's why computer science might also help you more in the grand scheme of things, not just in terms of skill set. Because at the end of the day, a 4-year course does not make or break your career. It might just save you some time in discovering where you're at, where you want to go. Because before that, it might not be really clear. Or you might think it's clear, but it might not be that clear, because maybe your picture of things might be somewhat limited. Again, Brandon, I'm saying you, but I'm applying this to everyone. Obviously, it's not just a matter of you. Principles apply to anyone in any field of study. So consider university more of a way to discover, and the more things you can discover, obviously within certain restrictions, you're not going to learn a bit of every course. You still need to choose a path, but you know, not having that too narrow is very important. And I think IT in itself already opens many doors. You can pivot very easily to other industries. My degree was in applied to biology, so bioinformatics. That I applied. I had a, not my degree, sorry, my dissertation, my final year project. I had done something with visualizing, again, the graphics aspect. Somehow, I'm just realizing that right now, as I'm saying it, the graphics element did get in there, it already filtered in. It was visualizing and solving a whole issue with protein chains and how the different elements which human body absorbs and ingests get you know, the different chain reactions which happen, and how those get recycled, and how the whole ecosystem happens. So for example, you breathe in air, and then there's the reaction, and hemoglobin and the oxygen get absorbed, and the oxygen goes into something, and that generates this and that, and carbon dioxide goes out again. So there's a whole chain of sequence of events where components, so elements and molecules, react with each other. They form different compounds, they break down different compounds, and it's a zero-sum equation, right? If you start off with I'm being, you know, silly example, but if you start off with 2 oxygen molecules and 1 carbon molecule, at the end of the day, whatever you put in and out, you must still end up with the same amount of oxygen and same amount of carbon, maybe in a different state, but you can't create stuff where it didn't exist or destroy stuff, right? I apply that to that industry application. So again, something completely different, which I did not pursue. I considered getting into bioinformatics, which I then changed into specifically memetic algorithms, because I had used a memetic algorithm to approach this. So I wanted to pursue an academic career, potentially, in memetic algorithms, or at least I said if I'm going to follow a master's degree or a doctorate degree, I do that with memetic algorithms in mind. But then, you know, life takes its twists and turns, and it all works out anyway. So, point being that it let me explore different areas, and I think IT and computer science, specific computer science, will let you do that. So, I think you made a good choice if you're going for computer science. I do not think you will regret it. Granted, I'm a bit biased in this because I've gone through that myself and I'm working with that myself. But I think many people would agree. If anyone who's watching this has any opinion, any opposing opinions, or something in agreement, feel free to sound off in the chat. And if you do have any questions about game development or something like this, something a bit more academic or something technical, or in anything really which you think I can help or give an opinion on or help structure some thoughts, you can reach out to me on Twitter at Caruana. The handle is right next to the webcam overlay on the stream. You can leave me a comment on YouTube, you can reach me on Facebook, or send me an email on stephen@GameDevElement.com. We can discuss it on stream, we can discuss it privately. It's up to you. So I hope, Brandon, that helped you somewhat. Let me know if you'd like to ask anything else. I'm undecided whether to call this a day, call this a stream, if that expression, that made-up expression makes sense. Whether we'll call it a day or whether I'll do some dev streaming, but it's in 20 minutes. Judging by what I normally do on a dev stream, I don't think I'll manage to do anything productive. Just for curiosity, in the program description, there was maths for engineering. Sure, so let me bring up the University of Malta website. So I'll switch to, I'll open up browser. Wait a second. So I'll see exactly what we're talking about. So let's bring up Chrome here. The screen is going to go white very brightly as I switch my stream scene. So get ready. There we go. So University of Malta, Faculty of ICT. Let's bring up the undergraduate degrees. Undergraduate, there we go. So these are the degrees. So we've got computer engineering, computer science, AI, computing and business, and software development. So in the program description there was maths for engineering. Could you tell me what it will be used for? So correct me if I'm wrong, Brandon, we're looking at this course, right? BSc in computer science. Now why these two are a BSc and these are a BSc IT, I have absolutely no idea. Back when I was studying this course, it was a four-year course. It was a four-year honors course. It was a BSc ICT degree. I have no idea what the distinction between these is. It's probably nomenclature, but there must be a reason why. I don't know how to answer that. But so in the program description, course overview, engineering. Do you know where it? So there was maths for engineering. Do you know where exactly they refer to that in the page so that I can read its context? But in the general case of things, so engineering goes into there's the software engineering and there's the hardware engineering side. So it depends on what they're referring to. In the software engineering type, well, mathematics goes into IT very strongly if you're into certain kinds of subject applications. So if it's academia or if it's certain programming applications, where it included the credit. Was it in a context of hardware engineering, so you know, CPUs and chips and gates and all that, or was it in the context of software engineering, so software design, software creation? If you can remember the context of it. If it's in software engineering, well, let's take graphics for example. Graphics is maths. It's mathematics essentially. It's A-level grade mathematics. It involves a lot of calculus and trigonometry. Let's take a specific example, shaders. You want to manipulate certain stuff and find certain pixels and move them here and there. That's A-level maths for you. Okay. So in the list of credits, let's take a look at that. Let me open the link. Copy link address. Okay, so these are the units, the credits. Probability, sampling, estimation. Okay, there's some very basic mathematics. It's more applying those mathematics with probability. So yes, A-level maths, but probability mathematics are not that complicated at their base level. You know, in terms of equations and all that, applying them gets more complex, obviously. Now we have mathematics of discrete structures. Okay, in this case, mathematics is more abstract mathematics. So it's more formulas, balancing formulas, representing stuff in a very abstract way, and formulas. If I'm not mistaken, these are Gordon Parch's topics. Alright, Christian Colombo, yes. Same. Back then they were Gordon's, Dr. Parch's topics. So mathematics for engineers, here we go. This is 1 and this is 2. Alright, semester 1, semester 2. Let's have a look. Analytical skills which are applied to problems in engineering. Differential equations, yes. First order, second order. Okay, alright, so it's engineering. This can apply to hardware engineering, but in this case I think it's software, right? So it's with Fourier transforms and all that. These are all mathematical stuff which might be partially covered in the A-level pure A-level, pure maths at A-level. Going into more detail, and they'll be used in they won't be used in your regular day-to-day programming. So you won't use them to program a business application like accounting software or real estate software or a website. But if you're doing the what I think are the cool applications of programming, like for example, a system whereby you need to monitor and balance the energy load on energy creating infrastructures like power stations or large energy consuming structures, and balance them out across a network in the European and Mediterranean area, which was a project I was working on back when I was still in a software house. So the non-traditional business applications which you can download from the internet, so really customized cool stuff, those get in there. So what this course will teach you is what these models are and how we can apply them into programming and where they are part of the solution. So the answer to your question is answered by this specific course. Computer science teaches you that, so you'll know that certain mathematical models exist and when they are a potential solution for a certain type of problem. Computer science will show you different type of problems you will be dealing with, and your knowledge will, after those 4 years of study, will be such that you'll know what approach to take. If the approach is a highly mathematical one, this course, along with others, will tell you, will give you the skill set to recognize that. That's important. You'll know what approach you should be taking. That is what a university degree will give you, whereas personal experience might take you away from that, or you might not get into this very easily, along with other courses which will give you that knowledge. So basically it's the mathematics will be used to analyze and process data, essentially, whether the data is numerical data, whether that data is graphical data, whether that data is a more abstract representation of something. You'll need to process it somehow. And stuff like series and integration and differentiation, those do come into play. Quick tidbit of information. With a course like this, where you look at Fourier transforms and all that, you will, at least we were, and if the course is the same, you will be very frustrated to learn that the long form integration and differentiation you learned at your A-level studies, pure maths A-level studies, could really be done much easier and in 2 lines as opposed to a whole page of equations which you need to go through. So that gives you, but you obviously need to know that rudimentary fundamental skills in integration and calculus and all that in order to appreciate this. So this will give you a specific skill set which you might be using in IT. So it's a narrow part of mathematics which applies to a wide variety of programming of IT, computer science problems. It's also related to certain optimization techniques. It might also be related to some concepts in concurrent programming. So that's where it applies. Discrete mathematics is non-traditional mathematics, so you won't be adding or subtracting stuff. You'll be dealing with set theory. You'll be dealing with stuff like A implies B, B implies C, therefore A implies C. That kind of logic. So it's more of logic. That's discrete mathematics. Obviously taken to a higher level where you can, if you remember your mathematical proofs, you'd grab proof by induction. So step 1, step 2, step 3, this implies this, therefore proved by something, or by proved by contradiction and this and that. Discrete mathematics is the reasoning behind those proofs. You can abstract any algorithm into discrete mathematics, so into basically letters and symbols and sets and notations, and you can derive your own proofs and prove that that data representation is sound, it's valid, that your program, or at least your that small algorithm, works. It happens in polynomial, MPC, time, this, and that. I'd end up mentioning a bunch of stuff which will confuse you even more, but that kind of mathematics. So in this case, you're seeing mathematics, but it's logic theory. Okay, data structures and algorithms. That's algorithms. Okay. SPSS. This looks like statistics. All right. Data communication. Okay, so this is the engineering side of things. That's where you might be using mathematics as well. So it's signal processing. If you've got an electrical signal, you've got a radio antenna and you get a signal, it's a sine wave or something. How will you process that? You need trigonometry, you need this, you need that. That's where the mathematics comes in. So processing signals in that case. So your data is in the form of numerical data. It's a curve, it's a plot, it's a time series. How are you going to process that? So that's where your mathematics comes in as well. This object-oriented programming I mentioned earlier, programming paradigms I mentioned earlier. It looks like the course hasn't changed significantly since I went through it. It seems relatively similar. There are some things which are missing from what I did. They introduced some smaller things. Okay, queuing theory and Markov chains, mathematics. That might relate to mathematics for engineers, because engineers in this case is software engineering. This is a new one. This is very interesting. This is very powerful. Digital signals processing, that might relate to data communication. This will involve mathematics. Compiler theory, not so much. Okay. I'm not sure if that answers the question, but it's that kind of mathematics. Concurrency distributed computing, that might have mathematics. Computability and complexity, that will relate to somewhat to discrete mathematics at a higher level, and to other stuff like data structures and algorithms and and programming paradigms and formal languages. So maths will be involved in that. Oh, okay, yes, expert systems fuzzy logic. That's not maths related, but that's an excellent example of where computer science trumps programming. This gives you the skills to know what you need to program. So whether you need to use fuzzy logic, whether you need to use an expert system, whether you need to use a mimetic algorithm, whether you need to use whatever. So that's in the realm of AI, of algorithmics, of artificial intelligence, machine learning, and all that. Quick example. Let me see if I can find that. What was that? That was a... this one, a genetic algorithm. If you've seen this, the computer, let me switch off the sound there. Neural network, that's it. The computer, someone programmed a neural network which learns, this is a visualization of that, which learns through trial and error how to navigate a Super Mario level. There is no one behind the controller. The program knows the 5 inputs of the game, so A button, B button, up, down, and right, and it learns how to navigate the level. It is not learning which buttons to push at the right point in time. It learns how to anticipate certain graphical aspects of the level, and so after training you can shove it any Super Mario level and it will complete it. Depending on the conditions you give it, it might complete it as fast as possible without losing lives, getting all the money and this and that. That is AI, that is machine learning, that is neural networks. That's an example of computer science in action applied to games this time. Computer architecture, okay, that's more of the hardware engineering kind. Networks, that might involve some mathematics. Graphics will definitely involve trigonometry and calculus. Oh, search and optimization. So think Google, backend, yes, mathematics. Yeah. So I hope that gives you a better idea of how the mathematics will be used. Going into more detail will require actually going through the module itself. So I hope that gives you a high level idea of what that involves. Yeah. Examination 2 hours. I'm not recognizing the name, so many people have changed, it seems. Some of them are still there, just out of curiosity. Yes, John and Chris. Coincidentally, they are the same two lecturers who used to teach that back then. Very good lecturers, very good course. Yeah, I think you're in good hands. So Brandon, unless you have other questions, by the way, I'm in no rush, but I don't think I have anything of substance to add off the top of my head to what I've already said. I've droned on quite a while on this. If you have anything specific, feel free to ask. The course seems overpacked for 3 years. I tend to agree. These were spread over 4 years. It was a 3-year course to get your general degree and the 4th year to get your honors degree. Actually, I lie. It was really 3 years worth of studying. 2 years, both semesters, 3rd year, first semester, and the 2nd semester we had applied practical tasks, which were massive assignments. We just had 3 in a semester. 4th year, first semester, we had lessons learning, and then the last semester, 2nd semester, you have your dissertation. So it was like 3 years, so 6 semesters of studies. But I think you still have some form of assigned practical tasks from what I've been told. In fact, yes, year 3 has might have 1 APT or something like that, and year 2 something like that. But yes, but the reason for this was to align the courses to more the ECTS system, to European standards, having a 3-year course versus a 5-year course with masters shipped with that, because now the university needs to start be self-sufficient, must start churning out master students. So it's more of a political thing. By politics, I do not mean politics in terms of government and political parties. I mean internal politics. It's a management of the education system of the university as an institution, getting in line with European systems and all that. So that was the motive behind it, if I'm not mistaken. Many other courses at university, many other degrees at university are following that pattern. However, it links back to what I said earlier. It's a rite of passage. It'll be hard, it'll be tough, but you'll come out of the end of it all the better for it. So do not be disheartened. It's not impossible, otherwise they would not do it that way. Many students have gone through it in this format before you. I think this format has been in there for the past 5 years. No, wait. We're in 2016. Ooh, I think closer to 2008. Yeah, 6 years maybe. So it's tried and tested. You've nothing to worry about. It's gonna be a challenge. I'm sure you're up to it. If there are any Maltese people watching the stream or live or on YouTube and you have any questions about this, I've gone through this course. Feel free to get in touch. Most of the topics are still the same. I'm sure I'm not that outdated from the theoretical aspects of things. Feel free to drop me a line. You too, Brandon. Don't worry one bit. Just fire off an email or a message, and I'll help out as best I can. In the meantime, that has been my take on the topic. I think I've been relatively rigorous. Yes, could you tell me about the final project? Well, I'm not sure if it's the same thing because I'm not seeing much about that over here. If it's the same as what we used to do. In our case, it used to be listed as a separate unit, so I could have clicked on it and seen what it's about. But at least in our case, you seem to have some elective units in semester 2, so I think semester 2 and semester 1, they're all elective. So you might be focusing, yes, on your final year project in your third year, not just in your second semester. It's basically a massive assignment. You'll find a tutor. Tutors will take maybe 2 third year top credit. Year 3. Ah, here we are. Oh, I didn't see those. Thank you. So there we are. Okay, so let's see exactly what it involves. Subjects, implementing a solution. Yes. Okay, fair enough. So it looks basically the same thing as what we used to do. So you'll be assigned a tutor, and by that, please understand that you'll need to chase and find a tutor yourself. Ideally, you start thinking about that early summer before your third semester, between your second and your third year. So at the end of your second year, start thinking about it. Find a tutor which is more in line towards what you like to do, the kind of massive project you want to undertake, which will involve a practical aspect and a written aspect, a dissertation. So grab your general assignment where you have a task to complete, a problem to solve, and you need to provide documentation with rationale, background study, and explaining why you made certain choices to a much larger scale, but essentially the same thing. The only difference is that you might need to come up with the problem you're trying to tackle, with the solution you want to create. You need to find a problem space which you can solve with CS techniques. You need to choose the right technique, show the research which led you to choose that technique. You might not be able to solve the problem, but depending on the kind of dissertation, the kind of final year project you're doing, not solving the problem does not mean you failed your dissertation, your final year project. The outcome of your project might be that solving this problem using this technique is not possible because of this, this, and that. And that is an excellent project to undertake. That's an excellent final year project, as long as it's not something which your knowledge should have told you at the beginning that it's obviously a wrong route to take. So that would be the merit of your final year project. Finding something which has not necessarily been solved in that particular way before, although similar things might exist, using your knowledge over the previous 2 years, 3 years, and industry knowledge, and reading about stuff and studying, applying that to a slightly different problem space and trying to solve it. If you solve it, you need to say why. If you don't solve it, you need to say why, and drawing conclusions, and that's essentially your final year project. That's all it is. So a massive assignment, basically, where you'll be given, full control over what your assignment will be. You will have certain criteria to fulfill. It has to be of a certain substance, has to have certain substantiality behind it. That is where your tutor comes in, guiding you whether it's a good project or not, whether it's a bit over ambitious, because it's easy to underestimate a problem space, whether it's too simple, and throughout the project that tutor will help you go through things. Do not rely on your tutor to handhold you. He or she will not do that, depending on how busy the tutor is, and that might influence your choice of tutor as well. So keep an eye out throughout the years on who you might want to approach. And you'll be somewhat guided into coming up with a solution. As I mentioned, my final year project was in this bioinformatics realm, so I actually managed to solve the visualization part was not that good, but the the graph traversal on which was a massive problem in the bioinformatics space, let's call it that. I did manage to provide a much better solution than what was currently available within obviously the limitations of a final year project. That was mine, for example. Others applied it to music, others applied it to engineering, but it's basically a big full year project, which will take up a lot of your time. Otherwise, it's not something which you won't have the tools to deal with. It's the natural progression of things, and that's it, basically it. Does that answer your question? If you have APTs, so assigned practical tasks, I'm not sure if they are still in the program. Those are basically somewhere between a normal assignment and the final year project. So a semi-large assignment is what an applied practical task would be, if it's still the same as back when I was studying. We used to have just 3 APTs during the second semester of the third year, 1 or 2 subjects, so that we could focus on those. So I'll slowly close the stream now. Brandon, if you have other questions, feel free to reach out to me on Facebook. Everyone else, if you have any questions about game development or want to suggest a topic for discussion on an upcoming GameDevElement stream, you can hit me up on Twitter at Caruana, leave me a comment on YouTube, or send me an email on stephen@gamedevelement.com. If you enjoy my content, you can support me by following me on Twitch and on Twitter, and by subscribing to my YouTube channel and liking my videos. So guys, thank you for joining me today. I hope to see you all again next Wednesday, same time, same place. And in the meantime, I wish you all a great week.